I'm going to. Take a couple bites of pizza. We also, I think, kind of, yeah. I'd rather have these. Why is it sharing? Oh, I get it. I get it. I get it. Why do we need AI assistance for this stuff? I don't understand. Okay. Can everybody see it okay? All right. So, welcome to RPIrates. Who's never been to RPIrates meeting before? All right. So, the RPIrates is the RPIR users group. I think we've existed for something like more than 10 years, right, Tom? Something like 10 years. And it's a highly informal gathering, approximately monthly. And what we try to do each month is to have some topic of interest. And if there's also time, we like to have a sharing of, what is it? It's feats of strength. If you've done something cool with R, we give an opportunity to talk about it, and airing of grievances, which is if you've got some gnawing problem that you've been trying to solve with, some issues, some bugs, something like that, we often give, share those experiences. And we also try to record these as much as we possibly can and share them via the RPIrates website. So we've got a whole selection of tutorials that we've done both through RPIrates and through the Kristen Bennett's data insight courses, data analytics research, or intro to data math. There's just a whole kind of library of tutorials that we've done and sharing that we've done. And tonight, what I thought we would talk about is, and I can't believe we haven't done this before, is talk through this amazing resource, which is Hadley Wickham's book, R for Data Science, the second edition. Hadley Wickham is the creator of the ggplot2 package. He's the creator of the tidyverse sort of meta package, this set of related R packages that share kind of an interface and a view of the data that they're looking for. He also most recently is the creator of the Elmer package, spelled like Elmer Fudd, which is a fantastic interface for working with LLMs from within our code. And so Hadley is the chief scientist of Posit, formerly RStudio, the company RStudio. They rebranded a couple of years ago when they embraced Python as well. But the company was known as RStudio, which was confusing because the interface or the platform is also RStudio, but they rebranded the company. So the book is a wonderful thing unto itself. It's beautifully done. It's completely composed in R, but the website is fantastic as well. They keep the website up to date. The second edition was created based on massive community involvement, and they keep updating it. So, and they actually update the book through Hadley's GitHub. So the book in general is organized by, the kind of the principles of data science. Get your data into R, how to get it, transform it into the most useful structure to do what you're trying to do, transformations, visualizations, communicate. This is Hadley, and it's kind of modest to look at. These are his pinned packages, and this is like an all-star lineup of the tidyverse, like that entire family package is dplyr, which is sort of the key. If the tidyverse is a Swiss Army knife, the dplyr is the big blade in the Swiss Army knife. R2DS, R4DS is the repository for this book at this website. Advanced R is his companion book, which is a deep dive, and I talk about it at some point in this tour. DevTools, if you've ever used install_git or install_GitHub, all those. Hadley is responsible for that package, which is really kind of an integration of several useful packages, and of course Elmer. And there's other things that as well. He's got tens of thousands of followers who are following his GitHub. So, and if you can catch one of his YouTubes, there's several YouTube videos out. He's a really nice guy. He's got a video that he was published in the last few months of where it's kind of a 20-year retrospective on his career. And it is very, very insightful. He talks about the evolution of his thinking as he went from before ggplot to ggplot to tidyverse, and how his philosophy has evolved. This is what you see when you first go to the R4DS or R4Data Science website. And I'll dive into all of this, but it's kind of his organization is, let's start really basic and kind of overview, and then let's kind of lay out our vision of and kind of in a priority order of doing data science with R, and then let's go even deeper. So it's a very novel structure. I call this data science in a nutshell. The things that are highlighted in blue are the general areas that R4Data Science goes into detail for. And I should say, every one of the chapters in the book is like a mini tutorial on that particular topic. You can work through, there's examples all the way through. There are, at the end of each of the chapters, there's actually exercises that you can follow. So it's a one-stop shop. If you say, John, how can I get started in R? I say, go to R4Data Science and just start going. Start with the introduction, and you'll step through. The introduction will just describe these various phases. In the general picture of importing your data in different ways. What's called tidying your data, putting it in this particular structure, this uniform structure, where it's one observation per row. And that is the uniformity that you have across the tidyverse, is that vision of one observation per row. If you've got data that's spread in what we call wide format, the various parts of the book will guide you in how you transform that into a tidy format so that you get, again, this one observation per row. And there's a comment here about how Tidy data is important because it's consistent structure, lets you focus your efforts on answering questions about the data, not fighting to get the data in the right form for different functions. If you get your data in this particular structure, it becomes very easy to especially apply filters in such a way that align with the questions that you're asking. So you can construct in your workflows well, it's true also of your selecting which variables you want to focus on, filtering based on the values of those variables in a very easy way. That's much harder to do if you haven't gone through this transformation. The transformation is what I just said about how you're creating subsets of your data frames that can narrow down those observations of interest, but also allow you within those pipelines to do summarizations and to augment your data set, whether you're creating data frames that just are summaries, or if you're mutating your data set by creating new variables, which are functions of your old data set. So that's what, like, creating counts or creating means. You can do this summary statistics both as standalone data frames or augmenting those things. It used to be said that the entry-level drug for R, like maybe 10 years ago, was the ggplot2 package, the grammar of graphics, which is a particular literate way to construct visualizations creating what's called or given a data frame, constructing that plot object and then adding layers, adding geometries, whether the geometries are points or lines or other geometries, statistical representations, theming, applying themes to your plot, doing this all in an elegant way that is also publication ready. It looks appealing, but is also publication ready to go. And it was no joke that people would ask the question, how do I make a plot that does this? ggplot provided the most sensible way to do that. You had to learn this platform called R to do it. And then they said, well, while I'm here, what else does R have? Well, wow, R's got this whole uniform way of doing statistics. It's got this set of packages that help me do data transformation, slicing and dicing my data. This is a pretty cool place to be. We all know that you can't, you're here for RPIrates? Grab some pizza and have a seat. Welcome. Visualizations aren't good enough. Modeling is where it's really at. We of course, there's a whole set of tools, including tidy-oriented tools for modeling your data. There's some arguments about, visualizations don't scale. There's a limit to what humans can sort of carry with them, but it's the modeling, it's your statistical models, your machine learning models that make the real difference. And the book does not, the first edition of the book actually dove into modeling and dove into the advanced communication aspect. Hadley and company refer to much better books that have been written by I think they're co-authored by at least one person from the Posit company and other people. I think Julia Silge, I think, is with Posit now. So there's a wonderful companion book to R with data science that's purely about modeling. And then there's communication. And the ability to publish your publication-ready results that are written in R and R Markdown has been one of the amazing advancements over the past 10 years. They're including a relatively new platform called Quarto. Some of us are familiar with R Markdown, but there's what I would say is R Markdown on steroids, which is this Quarto platform, which allows the easy publication of even books and other sorts of ways of publishing. So it's kind of like a formalization of things like what we do with R Markdown and Shiny and some of these other things. And we here at RPI have really not done, I don't know if anybody has done anything with Quarto. It's one of those things, and the book does not go into the Quarto side of things. Okay, now what I just outlined is the logical way that you do data science and do data science with R, but that's not how Hadley organized the book. Hadley organized the book in a much more exciting way, starting with what's the coolest thing we can do with R first, and it's visualization. So he boldly jumps right into, right into visualization, right into how do we, let's take a sample data set, let's transform it into something that we're going to use. He uses, like many of these tools, there are standard data sets. We know of empty cars. Penguins is also a very, the Palmer Penguins data set is another one. He uses he's giving sort of a basic tutorial of R and of kind of a jump in the deep end portal, trying to get you to, as fast as possible, visualizing. Glimpse is a subset, like shows you where we're going to go, and then steps through the basic commands. And what's really elegant about this approach is he's breaking apart the ggplot layers and showing you, trying to explain what it does and what it doesn't do. Like, I just take ggplot and I put my data in and nothing happens. Why? Because you haven't done anything yet. You haven't added layers. You haven't added this. So in this very first chapter, he constructs this, and I'm diving into this because this is the visualization introduction is an excellent example of how he does everything in the book. Okay, I'm showing you. This is a reproducible tutorial. You can follow along step by step, whether you're doing this in your own personal installation of R on your machine, or whether you're doing it on using the foci cluster on campus, or whether you're using some other cloud-based thing. You can reproduce this example and go step through, and very, very quickly here, and in a very understandable way, you are creating this very, very refined plot. And then boom, exercises. He's got a set of questions about this. And this is true throughout this book. It follows this model. You've gotten even like many of the exercises are based on what you've been working on so far. So how would you modify it this way? How would you modify it this way? Just going further and further and further and advancing it. And what if we do different kinds of plots? So these exercises are scattered through. The you notice that I'm showing the structure in a particular way. Chapter 1, chapter 3, chapter 5, chapter 7. So we did visualization, we jumped in the deep end. Then we take a step back. We pick up some concepts that were actually may have been hinted at in this previous chapter when we're getting our data ready for plotting, data transpiration. dplyrs, if we're familiar with SQL or SQL, we have selects, we have filters. dplyr applies the same slicing and dicing principles that query languages do to your data frames. Data tidying is a different thing. Data tidying is about reshaping your data frame, taking wide data frames and making them long, or sometimes vice versa. It depends on what your requirements are and the questions that you're asking. And data import, the first thing you do, they talk to you last. And the reason is they're trying to get you engaged and get you doing real things. And then we get to the messy, the messiest of all, which is how do we bring in data that comes at us in different ways, data that might look really ugly, data that might be in different basic formats, data that might be in databases. The only thing that they don't do really much of is, or at all, I think, is how do you deal with graph data, but they do deal with nested data. So each of these, and I should say, these links are for real. This slide set is going to be available in PDF format from the website that I created for the webpage I created for announcing this talk that's in the email. And it will also be available at the RPIrates website. So you can use this as a jumping point to vector into each one of these things. So, interspersed between these chapters, the missing chapter 2, the missing chapter 4, 6, 8, these are more, whereas this side of it are coming at you conceptually. How do I do slicing and dicing of the data? How do I do reshaping of the data? How do I bring the data in? Here, we have chapters that are focused on really on coding in different ways. So the basics, how do I just understand like the basic syntax of R and peculiarities of R, things like that, even comments. What do comments look like? So there's this sort of, it's probably a lot like teaching a foreign language. Let's throw you in, let's start talking German to you right away. Ich weiß nicht, was soll es bedeuten? And then it's like, what is he talking about? Well, it's like break it apart. This is how we do assignments. This is how we write calling functions. So basics. Then we go back to, we go into data transformation, then style, coding style. There's one of the most interesting things is when they decided that there needed to be an R style guide. It was then called R Studio, now Posit, referred to the Google style guide. Okay, Google had published an R style guide, and Google published a Python style guide. 10 plus years ago, there was this, I don't think the segmentation is there now, but within Google, you had data scientists that were using R, and you had like the software engineers were using Python and other things. So all going on in the same company, and they were very public about it. Very quickly, the R people had some things about style. They started kind of curating this. They said, well, we liked the Google's R style guide, but we also need to do this. Very quickly, Google said, what they say. So Google started referring to the first R Studio and then Posit R style guide. And then Tidyverse style guide kind of embraces, it brings into the fold sort of the principles of this Tidyverse particular way of piping together functions. Scripts and projects, this is, if we came into R, such as our students who do intro to data math or data analytics research, you start at the beginning, coding in notebooks and writing scripts. But there's no assumption here until you get to here that you're actually like saving code. Okay, you could just as well be coding interactively up to this point. And here you get to this point of like, you can actually save this in a file, a script file, a .r file, and this is how you can call it in different ways. And oh, by the way, there's also this notion of projects, and you'd have to go. I've done previous RPIrates on this notion of projects. This is probably the way we should be doing it in data analytics research. We don't, but it's a way of kind of having more shareable and more managed environments. So scripts and projects, and finally, maybe this should be first, is how do I get help? And this is incredibly practical. They completely recognize the fact that if you Google on a problem that you're having, an error that you're having, your solution is probably in Stack Overflow somewhere. Okay, so they talk about how to Google the problem that you're having in R and get a reasonable result, and and this is very important, how to ask a question so that the trolls don't attack you. But this is also true. This is even true if you're emailing RPI support by some problem that you're having with a system. What is your reproducible example? What can you say? What question can you ask that allow this person who's going to be helping you to reproduce the problem that you have? And there's actually there is a R package for there's a R package that helps you create reproducible examples, or helps you create in the sense of formatting it so that you can copy it and paste it into, say, Stack Overflow or GitHub as a GitHub issue, and have it be properly represented, have it be represented as code. So it looks like a very nice thing. So this is actually the structure of what I would call the second part of the book. The first part of the book is this introduction that goes through the entire data science model. The second part of the book is this, I think they call it the whole game. The major section of the book is called the whole game. It steps through each of these chapters, and at this point, you're ready to rock because you've gone through each one of these. There are detailed examples, and I got ahead of myself previously that every single chapter is structured the way I showed you with the visualization chapter on providing a thing. Here are the references to. Some of these are really So tidy modeling with R is kind of specialized. It assumes that you are doing models that kind of follow and are consistent with this tidyverse notion of tidy data, which totally makes sense if you're using tidyverse for slicing and dicing, if you're using tidier for reshaping your data. What then is our approach to modeling? Big data. You may find yourself using this and using the data table, and data table is kind of a family of packages, but it's it in many ways is a more manageable way to handle efficiently big data than vanilla data frames are. With data table also comes some special rendering capabilities, special ways that you can visualize tables. For example, we use them in the Mars Mission Minder app a lot. We use data tables for displaying results. There's a package called DT, capital D, capital T, which is used for, there's some very elegant ways that you can display tables interactively, so you can sort and that sort of thing. So big data. The R for data science does not deal with Shiny at all, creating interactive web-based apps, reactive apps in R, but Shiny, of course, is 100% consistent with the tidyverse. And then what I call deep R. Advanced R is a very, very thoughtful book written by Hadley. It's also a website, just like R for data science, Advanced R. It's I call it out for creating R packages. It's not specifically about creating R packages. It's just a deeper, it provides deeper insight into coding with R, which includes some principles that you really need to have a handle on if you're ever going to release a package in CRAN. Or if you're going to be so bold as to just make a package available to other people on via GitHub. It's one of the things that's kind of beautiful about the R universe is it's getting your package released via in CRAN, which is CRAN is the global repository of R packages. It's a very high bar. And I know of one person at RPI in the last 10 years that's done it. And it's Hannah De Los Santos, who was the creator of multi-window Shiny, which is what we used in a campfire. That's the only package, the only person I know to even attempt it, really. But it just, and I'm amazed that she did it because but she was a very diligent person. And then there are the other things that are not discussed in the book. It doesn't talk about interactivity with compatibility with Python or Julia. That one person was asking about Julia, other things like that. It's not about that. It's about R. In this church, we talk R. Okay. Then what's really interesting is yeah, go ahead. I'm sorry.
I have to step out because I have a video call at 6:45, but you mentioned you were recording this.
Yes, I am.
Are you were you uploaded anywhere?
Yeah. So did you find out about it? How? Through
email.
Through email. In the email, there should be a link in there. There's also, there's an RPIrates email list, but and RPIrates, there's an RPIrates website on idea.io. idea.rpi.edu, there's a link to RPIrates as well. But if you look at that email, it should be a link to what I call a kind of it's a page about this event today. And I will update that with both these slides and a link to the video after it's finishes baking. It's got to bake overnight. And okay. Yeah. Thanks for coming. Then take food with you. Don't leave it all for us to eat. And eventually I'm going to eat my pizza. So if the intro is part one, and if the,
Yeah, but like, why do people?
don't worry about it. Just take what you want.
Sorry.
You can take a whole slab of it. Go ahead. Yeah, go ahead. Thank you. You've done us a favor. You've done your housemates a favor. If part two is quote unquote the whole game, which we just stepped through, then part three I would characterize as a set of deep dives where they're returning to some of the topics that they discussed before. For example, these three chapters, which they call visualize, and it's breaking apart in much more detailed ways things that aspects of visualization that they only would have touched on very lightly in the chapter focused on visualization. Okay, so much more detail on what are aesthetic mapping. So what that is what defining which variable is X, which variable is Y, which variable is the color, which variable shape, how does this apply from the standpoint of my plot object versus if I've got individual geometries, like I've got a layer which is a scatter plot. How do I define the aesthetics for that scatter plot on that? When I layer that point layer on there, how am I coloring it? How am I doing the shape of that versus what I've defined at a higher level? If I've got multiple geometries, how do I differentiate that? How do I do do things like having a plot with 5 different variables, 5 different oxide levels being displayed at the same time? How do I do that? How do I make sure the colors are different? How do I keep those colors from plot to plot? How do I create faceted plots? So if I've got the particular plot but I want to vary it by some factor or variable, how do I include in my plot stack, my pipeline that I've constructed, my layers? How do I include statistical transformations? How do I plot? In some of these geometries, ggplot can do this stuff automatically. And then there's all the fiddly stuff, like how do I move this around? How do I put this down, move this to here? How do I move my legend around? How do I deal with themes? There's a tutorial that I have online, which I've done many, many times live, where we recreate a plot that appeared in The Economist magazine, and we use ggplot to reproduce it as precisely as possible. So it's a plot that was done in some other tool like Adobe Illustrator, and we use by careful construction, careful layering, we're able to reproduce that plot almost exactly the way it appeared in the magazine. So it's just a set of choices, and it's very clear and very literate. How do we adjust our coordinate systems? How do we scale? And then kind of a generalization. This chapter kind of ends with some motherhood statements about the general principles of, uh, of this grammar of graphics. And again, this is an example of kind of I think what the elegance of this book is they introduce these topics to you and give you examples, and then kind of come back around and explain the principles that are at work in it. It's a great way to teach this. There's this section on exploratory data analysis, which is how do we do visualizations in a part that is actually contributing to our analysis in particular ways. And they get into much more depth, and we get into talking about how do we do plots that emphasize anomalies, covariation. And then we get into kind of the where they to some extent they touch on kind of polishing and fine tuning your plots. Here they just go into great detail, and this is probably there is so much of Stack Overflow is populated by questions on in dealing with how do I do this? How do I change my labels? How do I annotate my plot in a particular way? How do I have adjust this discrete scale? How do I set my colors to my legend? How do I set my legend to my colors? Different, whether it's customizing your themes or using accepted themes in just general layout. So, and these come back in particular if you're trying to make a publication ready plot. It's right in here. So for those of you in data analytics research that are getting yelled at by, why don't you label your plot? Or I think your plot, blah, blah, blah. All your answers are in there. Okay. So that section was the deep dive. Those 3 chapters were deep diving into visualization. Look at the number of deep dives that we have for transformation. So you can see how he structured this. We started previously in the whole game learning kind of the general principles for transformation, but now we dive really into depth. We really explore logical vectors, including like details. It says how to create them. So how do I do things like comparing 2 vectors and producing a logical vector based on the comparison of those, but then how to apply that. Various tools for dealing with vectors and numbers. The fundamental structure in R is the vector. Actually, it's a list with metadata makes it a vector. This is probably the amount of times that I've had to look up how to deal with strings in a particular way. How do I chop columns apart? How do I put columns back together or join columns together? How do I edit columns to remove or add something? The strings chapter, mostly focusing on the stringer package, which is a tidyverse package, where the classic cases. I've got a data frame. I've selected. I've filtered. I want the data in that column to be appended by something. Say, looking in there, I think this is an example. You had an example today where I mentioned, well, maybe you can put like the campaign at the appended to that. Stringer is the kind of thing you would use for that. You'd stick it on there. Regular expressions. How many people have heard of regular expressions? How many people have actually used regular expressions for real?
Well,
in anger? I've used regular expressions in only very primitive ways. You couldn't even say that I've used like the default mode of a regular expression. It's not really a regular expression. It's just, a pattern match, but they go into great depth in this chapter. Factors. So we think of factors as, as these categorical variables, the variables where they're essentially string variables where they're constrained to certain values. But understanding how factors work lets you solve problems like you're doing this plot and your x variable is a vector of strings, and you want a specific order. And you want it to be the order that you have it in your data frame, but every time you try to plot it, it comes out in alphabetical order. That's not what I want. I want it in a different order. Well, by converting that vector to a factor and assigning the levels for that, you're able to specify exactly the order that you want. Okay, so even though it might have occurred in one particular way, like say you have, I don't know, a data frame, a vector that is something called, abrasions. Okay, and you want it to be in a particular order. You make that a factor. You assign those levels. I don't think it's values. I think it's levels, a particular order, and then it'll automatically, when you use it as a factor, it'll be in the correct order. Okay, and that's a legit use. That's not a hack. That's a legit ordering of a constrained set of values. Lubridate. Lubridate is another tidyverse package which answers all your questions in terms of manipulating dates and times. It's amazing. It's like, I've got this crazy arbitrary way that these people created dates and times in this column in the CSV I got. How do I convert it to something? How do I convert it to an actual date? How do I, given the arbitrary format that they created, how do I make it so that that date works in a way that R knows it's a date? Okay, Lubridate. And it does it in a way that's totally consistent with the rest of it. Missing values. There's a lot of things you have to do with everything concerning an NA, and including how do I backfill in different ways. So there's a whole section, and then multiple different ways to solve the join problem. And this is a nice, gentle introduction to this. Those of us who have been working with databases and rectangular data structures and all this kind of stuff for generations, it seems, kind of intuitively know this, but this teaches you this notion of the key that you have in a table, or the key that, what is a key? What does it mean to have a key to like a data frame, and use that with a key from another data frame for linking together and perhaps expanding? Like, this answers the question. I've used different words. How do I, given the value of this vector here, how do I look up this other variable in this other data frame and add a column to it, fill in this new column in my data frame? That's called a join. There's many different kinds of joins. There's left joins, there's right joins. There's other functions that you can use within R that do things a little bit more smoothly. There's a merge, which is sort of like a left join with some default set. But again, this is each one of these just goes into more depth. So we can see this pattern in the book is earlier on, we got an idea of transform. Now we go deep diving into each one of these different aspects of transform. And you should view these not as, you would never like teach it in this way. Okay, think of this more like a reference. Okay, and now the assignment is to go home and look at the whole book. Okay, and then there's as we get to, if you remember the kind of the structure and how in this inverted row, inverted order, import, which is actually what you would think you would do first, bring your data in. They cover towards the end of the book the different ways of importing. I think they probably dealt with importing CSVs earlier on in kind of a trivial way to read CSV. How do I deal with the subtlety of importing Excel spreadsheets? What do Excel spreadsheets have? They have multiple tabs, right? What do real spreadsheets have? They have garbage rows in front of the actual part of the spreadsheet that is for real. Or maybe they're not garbage. Maybe there's useful information on those first couple rows of that spreadsheet before you get to the rows that the row that actually specifies the column headers and the data. So the book addresses how to deal with real spreadsheets, not polished CSVs that you're given, and Google Sheets, how to retrieve based on the URLs of those sheets, how to pull that data in and also deal with the same realistic problems that you have. How to get to a particular tab, how to ignore certain rows, how to subset it before I bring it in. Spreadsheets, databases, how to hit a relational database, different kinds of databases. What they don't do is they don't really deal with like graph databases. They don't deal with like linked data like you might have in like Sparkle queries or something like that. If you've got questions about how to get at those kind of databases, talk to me. I've been doing those for almost 10 years. There is a special, so there's Apache has this thing called Arrow, which is a way of accessing huge data sets in what's called Parquet format. And Tom, we were talking earlier today about our big data course that we did 10 years ago. There was a way that you could access huge data sets that we had back then. This is sort of this Parquet format and this Arrow thing are kind of similar to that, where you use the same techniques that you would use if you had just loaded your data set into memory for slicing and dicing, but you don't load it actually into memory. You access it essentially from the disk. Hierarchical data. This ought to be titled, "How the hell do I deal with JSON?" Okay, and JSON is how many people are familiar with JSON? How many? Yeah, and it's a nightmare to walk the nested structure. R actually has some really nice tools, including the JSON Lite package for dealing with JSON, for figuring out how I can read in and subset that structure and end up with a nice data frame. It's easy to get JSON in, but you don't necessarily get what you think you'll get. You could end up with a kind of, as it says, nested list. You could end up with kind of a mess, okay? But you can actually, there, with some tweaking and stuff, you can actually get some, you can do it pretty nicely. You can, but you can also deal with lists pretty nicely. R handles lists pretty well. Okay, and then web scraping. And I have an app that I created years ago that I use for, I live on a lake in New Hampshire. And I don't actually live on the lake, I live next to the lake. But the Department of Environmental Services in New Hampshire has a website. Is that what I use it for? No, they created an API. I used to hit their website, and then they created a nice API that I hit now. So I switched from scraping their old website to get information about the lake level on Newfound Lake to actually converting JSON that I read through the API. But what I do use the web scraping for is I have another app that I created a million years ago. It's called Wordle R. It's an R-based Wordle wizard, and I use it every morning for doing solving Wordle. Hasn't lost yet. I created it. I played Wordle. Played Wordle like 3 times, and I said, I'm going to write an app for this. This is stupid. And this is back when Wordle was still in like 100 days into it. And now we're at 1,570 something. Okay. And I've been playing Wordle using R since. But one of the things it does is periodically, every couple of weeks, I go out, my code goes out to a website that has all the Wordle answers, the previous Wordle answers, and it scrapes this website, and it factors in the solutions and eliminates the solutions from the guesses that it's going to do. And it helps nail it down. I start off with the new list of 5-letter words, which is 5,000 some, and then it slices out this, it slices out plural nouns, it slices out solutions, gets it down to about 3,000, and then we start guessing. Anyways, and then finally we get into a deep dive into programming, a lot more detail about coding up functions. But what's useful about this approach to it is how to utilize functions within your tidyverse pipelines, your dplyr pipelines, so that you are you're doing efficient codings in a consistent way. So it's not just, so yes, we all know if you repeat something more than twice, you should write a function. But sometimes it's not obvious the really smart way to do that within your tidyverse code. So this provides specific advice about that. I'll admit that it's a lot easier for me to tell you to write functions than it is for me to apply that discipline to myself, because I'm a code as I say, not as I do, is my thing. I'm bad. Iteration. If you are writing for loops in R, you should take a step back, because R is nicely vectorized. A lot of what you do in R can be done simply by applying a function to a vector. Sometimes applying a function to a vector, or applying one of the apply functions to, there's lapply for applying a function to a list. There's mapply for applying a function to a matrix. Whether it's just natural vectorization or using apply, there are really sweet ways to avoid having to write loops. And one of the big mistakes we have where people have some like Python experience and they come into R, they immediately say, well, I have to iterate through this structure. I have to iterate through all of this. It's like, no, you don't. You know, you can do it. You can probably do it just by applying it to, you know, your function to, or whatever you're trying to do. Sometimes it takes a while to think through it. And then they have, this is a really funny, a funny chapter because it's this book, because it's written by Hadley Wickham and we endorse it because our whole pedagogy in the data insight pathway is a tidyverse oriented approach. There's base R. What is base R? Well, base R is what you get when you're not assuming tidy data, when you're not using this family of functions. A sign of this is like you go to Stack Overflow and somebody's asking, how do I plot blah, blah, blah? And they're using the plot function. They just like plot and this, and it's, and there's a whole set of things related to that. Danger, Will Robinson. You know, what it does is this chapter differentiates how this thing called base R is different. Don't let your friends rely on base R. And then finally, so this is kind of unexplored territory for myself and a lot of people is they've really invested, Posit has really invested in this whole advanced way to publish. We started with R Markdown, which was meant to mimic just bring the principles of Markdown into R, it's kind of the way that they built our notebooks. They expanded with knitting, which is kind of outlined here. You know that you can use Knitter to create these different formatted things. You could publish those documents on this thing called RPub, which is kind of this open way to publish individual documents. But they created this whole empire called Quarto, which is kind of an advanced form of Markdown. Instead of creating RMD files, you're creating QMD files, and you have some advanced functionality. Like you can in addition to what we know we can do with our Markdown, we can also publish in this consistent way dashboards, websites, and Hadley's book is published using Markdown, using Quarto. So that's the and I believe it doesn't require paid membership to do basic publishing, but Quarto is kind of the ultimate thing, and I've longed to get my head around it so I could actually do an RPIrates just on Quarto. I haven't, except for doing basic tutorials, I haven't published anything on Quarto. And you can get a long ways without doing anything like that. But this is, I'm sorry I kept you long. But this is, you can tell I'm very excited about this. It's a tremendous resource. R for data science is just a tremendous resource, and it's a real tour de force in R, and it's a great way to. It's important to realize that there is this very methodical, very well thought out thing that you can use thinking through how to solve the problems in R and not rely on Googling everything every time you have an issue. Think of it like if I didn't have ChatGPT to write my code, well, where would I go? You go here, or ask John. All right, so that's it. Any questions? You can plot, it's okay. And by the way, eat pizza, feel free to eat pizza. So how many people have actually accessed it? Are for data science. We've in IDM and data analytics research, we've recommended it as a resource, but have you ever looked at it or? No. Now will you? Now will you? Now will you? Tom, have you ever? What's that?
Bits and pieces.
Bits and pieces.
The cheat plot stuff. And some of the data table stuff.